Okay, so now we're going to do concavity, which is the second derivative test. So again, the name kind of lends itself. If it says use the second derivative test, clearly you got to use the second derivative. Concavity is like glasses, like the shape when it like I have glasses, like it like curves in or whatever. And the directions say find the open intervals, okay? So I want to go ahead and warn you that I just worked out this problem before I videoed this, and it's pretty detailed. So I may have to put the phone down while I'm videoing some, and that's okay. I'm not going to stop it. I'm just going to push through it, and so if it gets fuzzy, I'm sorry. I'll pick back up. Also, if you need to pause and rewatch this video several times, that is also okay because this problem is pretty detailed, okay? So before we can find the second derivative, we have to find the first derivative. So I'm actually just going to go ahead and write this as 6 times x squared plus 3 to the negative 1 so that I can not have to do the quotient rule. So my first derivative, I'm going to have negative 6 times x squared plus 3 to the negative 2 times 2x, and again I'm going to clean that up, and I'm going to say f prime of x equals negative 12x over x squared plus 3 all squared. Okay, that's first derivative. Now I got to take second derivative. So second derivative equals, and I'm going to be stuck doing the quotient rule right here. I could bring it to the top, but honestly it's just lengthy either way. So I'm going to have x squared plus 3. Well, we have to square the bottom, and it's already squared, so now it's 4. All right, so I have the top, or on top, I have the bottom, x squared plus 3 squared times the derivative of the top, which is negative 12, minus, because it's a quotient, minus, big old bracket right here. The top, which is negative 12x, times the derivative of the bottom. Well, the derivative of the bottom, I'm going to actually have to have the chain rule again. So I have 2 times x squared plus 3. When I decrease this by 1, now it's just to the 1 power. I don't have to put that times the derivative of the inside, which is 2x. Now I'm going to close the big thing, okay? So let's clean it up. And we have negative 12 times x squared plus 3 minus, again, I'm going to work on cleaning up, 12x times 2 is 24, negative 12x times 2 is negative 24 times 2x is negative 48x. Still got that all over the bottom. Okay, let me sit up and get this. Okay, so now let's clean it up even more. This is going to turn into plus 48x, okay? So I see 1, 2, 3. I'm going to pull out a GCF. I'm just letting you know on the bottom I'm going to cancel it. I have a GCF here, here. And if I look at negative 12 and 48x, I also have a GCF of 12. So we're now going to say, I'm going to pull out a negative 12 because I like my leading term to be positive. So I'm going to pull out a negative 12 x squared plus 3. And let me color code if I can. So now that's gone right there. That's gone right there. That's gone right there. Where did I lose a squared at? This one was supposed to be squared. Okay, so it's gone down to 1. Okay, that one's gone. I'm decreasing that to what? I'm done color coding. I still have one of those, so I have x squared plus 3 left. And I have minus 4x. So where did I get that minus 4x from? Because 48, when I pull out that negative 12, that does give me minus 4x right there. That one totally went away. 2, and it had a 1 right there. Remember, you cannot give more money than you have. So it's like this person had $10 to give, and this person had $5 to give. And if they have to give the same amount, they can both only give 5. That's why that one was left, okay? All over x squared plus 3 to the 4th. We haven't changed the bottom yet, but now I see, color code again, that and that are gonna cancel, okay? And so now I have negative 12 times That was supposed to have a square with it. Oops. Negative 3x squared plus 3 all over x squared plus 3 to the third. Still not done cleaning it up, and I'm going to have to get another sheet of paper here in just a second, okay? So I have f prime double prime of x equals, I see another GCF right here between those 3's, and I'm going to pull out again a negative 3. So now I have positive 36 on the outside, and when I pull that out, I've got x squared minus 1 left all over x squared plus 3 cubed. This is my second derivative. I am going to pause for just a second, get a new sheet of paper, but I'm going to continue on the same video, okay? That is very lengthy. That is the second derivative. So now, within this second derivative, we have got to look at our concavity, okay? So, how do I figure out what my concavity is? Well, I'm going to take the derivative, the second derivative, so I have 36 times x squared minus 1 all over x squared plus 3 cubed, and I'm going to set it equal to 0. What to do? Well, I'm going to take it to the top, and I have 36 times x squared minus 1 times x squared plus 3 cubed equals 0. I'm going to set all three of them equal to 0. So I'm going to say 36 equals 0. I'm going to say x squared minus 1 equals 0. And I'm going to say x squared plus 3 to the negative third equals 0. So I'm going to work it. And then I see that's not a real number, right? So when I solve this, I get x equals plus or minus 1. So there's two critical numbers. And if I do this, I get, if I take this to the negative 1/3 to 0 that thing, that x went out, I get x squared plus 3 equals 0, x squared equals negative 3. If I try to take the square root of a negative number, we know that's not going to happen, okay? So we need to set up our thing. So I have negative 1 and I have 1. So let's look at numbers in between them. And so I'm going to test the value of negative 2, 0, and 2. And here's the kicker. I'm doing the second derivative test, and so I need to go into the second derivative. So when I plug negative 2 into the second derivative right there, I get a positive number. Okay, you can do that on your own. I'm not going to take time on this video to do that. And which that would be not increasing, because we're not figuring that out. Increasing is first derivative. We're looking at concavity, and so this is going to be concave up because it's positive. Okay, when I plug in 0 to the second derivative, I have what? If you do that right now, you can pause me. I get a negative number, so that means it is concave down. If I plug in 2 to the second derivative, I get a positive number. You can do this on your own. We are plugging into our second derivative right there, okay? Which means concave up. Now, here's the kicker. We did all of this for concavity, but concavity goes along with increasing and decreasing. So we're talking about concave up, means I'm looking like that. Concave down means I'm looking like that. Concave up, it means I'm looking like that. So you can figure out if it's increasing, decreasing. Could you do increasing and decreasing in this same problem? Yes, you would just go back to your first derivative and do this whole test, and you could come up with what the graph looks like. You could find your relative maximum and relative minimum all by doing this, okay?